they're all steps and, oh, okay, good.
Ready
Then
to go.
we'll start again. Basically, we're going to be talking about the A2L and the A3 refrigerants. It's what you need to know as we progress through the industry to making these changes. They're ongoing upgrades. They're not going to stop. It's going to continue to improve the global warming information that we are all seeing. So that's, oh, it switched back to the, okay. Now, this is just a quick bio of myself. I was a technician, a contractor, an educator. I was in charge of all the questions at NATE. I am a lead assessor for the American National Standards Institute in regard to accrediting people who hold certifications. I was the director of education and examination at the RSES. I did 5 years with True Manufacturing, teaching about the A3 refrigerants. So it's just a quick bio of what I've done all these years. But we're going to cover these subjects, and we're going to talk about the transitions from A1 to A2Ls and A3s, what global warming is, and what the low global warming refrigerants are, the standards and regulatory updates and the environmental considerations, what the flammability classifications are, and how you get to those classifications. It's an interesting subject on how that's determined. We're going to talk about some of the flammable refrigerants, what knowledge you require for those flammable refrigerants, and the installation and service information. So as you can see, we're transitioning to new refrigerants. Most of them are going to be more environmentally friendly. We've gone from CFCs to HCFCs, to HFCs, to HFOs, to HFO blends, and to HCs. And it's our industry is constantly in change. The reason for the newer refrigerants is the environmental condition considerations and the energy efficiency are the main drivers for these changes. The transition information is kind of critical to understand. We're going to be phasing down and phasing out the old refrigerants. As you know, CFC was phased out in the mid-90s, if I remember correctly. It started in about 92. I still have a bottle of 12 somewhere. So I don't know if it's worth, a new ring for my wife or not, but it's probably got about 10 pounds left in it. But we're going to see these things because we have to remove the issues of global warming that we're issuing and having. So the phase down reduces the production and import of the refrigerants and the percentage that's allowed to be produced. But the phase out means that the future supplies are only going to come from recovery and reclaiming. So recovery, recycling, reclaiming is becoming more and more critical. If you look at the following refrigerants, you can see what their global warming potentials are. HFCs have very high global warming potential. I mean, look at 410A. Global warming potential is 2088. When you look at CO2, it's 1. And we'll get to discussing why CO2 is the benchmark, but 404 is 3,900. But then you get into 1, 2, 3, 4, YF, its global warming potential is less than 1. And propane only has a global warming potential of 3. Now, CO2 is the benchmark. It's set to make sure that we have a measurement against something. And when you look at it, you say, well, where is this CO2 coming from? Well, for them to manufacture CO2, they suck it out of the air, they clean it, they purify it to AHRI 700 standards, and then if it leaks back out of the refrigerant system, it's a sum 0. So that was the decision that was made to make it a 1, and then everything else is measured against that. So we're in good shape with having a benchmark to measure everything. The low global warming potential refers generally to our HFOs and the blends and the HCs, which are mostly naturally occurring refrigerants. You have to look at it as, we no longer are using CFCs and HCFCs, so we don't have to look at the ozone depletion potential anymore. But as you can see, 22 is literally 0.055 in ozone, but look at its global warming potential. When you start to see these global warming potentials, you say to yourself, well, all this stuff is adding to an environmental condition that needs to be changed. So these things are changing. Generally, global warming potentials for cooling equipment is typically around 750 GWP or less, but it really depends upon your location. California naturally has different standards. Other states are looking at different standards. They're changing their GWP requirements on a faster basis. And for commercial and industrial applications, GWP is usually about 150. So you're going to be looking at refrigerants that are going to be constantly changing. They're more efficient, but they're going to do a good job of saving the atmosphere. Now, as you know, most refrigerants are now regulated, and most of our equipment has to be tested and approved by a testing lab. Products are tested by ASHRAE, EPA, UL, and or all of them. The AIM Act allowed the EPA to start to regulate and phase down some of the refrigerants that you saw that were being phased down earlier. The restrictions complement the broader production and consumption phase down of transitioning more quickly away from the HFCs, and it gives the industry more flexibility and more time to complete the transition. The regulatory impacts are, over the next 15 years, we're going to have an 85% phase down following the Caligli Amendment to the Montreal Protocol. The Montreal Protocol goes all the way back into the early 90s or late 80s. So these things are affecting us 40 and 50 years later. But as you can see, the reduction impact will hurt light commercial equipment and residential AC really in 2005, and commercial refrigeration from 2004 to 2024 to 2026. This is the kind of impact you're seeing. The baseline for these reductions is 2011 to 2013, and you can see the line that runs straight across. In 2022, we had a 10% reduction. By 2024, it's going to be like dropping off a cliff, bang. And we've got a 50% overall reduction in what we're going to have out there in the market. And these are just going to be some of the effects that you will be facing out there in the field as we go along. So these major changes are coming, and that's why we're going to the new refrigerants. Now, you've all heard the word SNAP, and it's the EPA's Significant New Alternatives Program. It's actually part of the Clean Air Act. It's one of the sections, and it created the SNAP program. Its job is to identify, evaluate the substitutes for the ozone depletion, but it also covers certain other things. And what you have to see is, okay, SNAP 23 cleared the way for replacing the high GWP HFCs in the AC sector. SNAP 22, which was approved way back in 2011, if I remember the date correctly, approved R290, R600A, and a blend called 441A, which is a blend of propane, isobutane, and such. And that's how many different SNAPs there have been. Actually, there's one more after this, but SNAP 23 approved the A2L refrigerants in multiple applications. They're in residential and light commercial air conditioning and heat pumps, So you're going to start to see flammable refrigerants in our air conditioning and heat pump sector. You're also going to run into the following different list of refrigerants: 452B, 454A, 454B, 454C, 457A, and R32. These are all the different refrigerants that are being approved, but there's a big set of words that goes after them all, and it's called acceptable subject to use conditions. In other words, it has to be approved for that specific use. If it's approved for light commercial refrigeration, it only can be used in light commercial refrigeration. It can't be used in air conditioning. So it's just one of the many things that you're going to experience as we continue on. SNAP 25 added 6 more acceptable refrigerants: 1234YF, 454A, 454B, 454C, 32 again, 452B. Again, it's subject to use conditions, but they're for use in non-residential dehumidifiers. The updated use conditions for 32 are for self-contained air conditioning and heat pumps for residential and light commercial use. So you can see how many different regulations are affecting all of us. But it all has to do with flammability. Now, does anybody in the room know how they test for flammability?
Cleveland open cup test.
Pardon me?
Cleveland open cup test.
Well, that may be what they call it, but it's actually an ASTM standard, and it's been slightly modified by ASHRAE. And what they look for is the lower flammability limit, the minimum ignition energy, the heat of combustion, and the burning velocity. You all know how propane burns, all right? But these are the percentages of propane that you have to mix with the air. Has anybody ever sat next to an open can of gasoline while you're cleaning some parts and had somebody come up and toss a cigarette in it? Well, I'll tell you, the cigarette will not start the flame. The cigarette will get put out in the liquid gasoline. It happened to me one day. That was enough for me to start to look at stuff and saying, okay, it's got to be converted to a vapor. It has to mix with the right amount of air. So these are the percentages. The lower flammability limit is what you're critically going to be looking at, because you don't want to have an issue where the refrigerant is going to have the capability of igniting. You want to keep it below that lower flammability limit. And part of the A2L issues will be if they're being put in homes and other structures like that, you're going to have to check the volume of the area, and the manufacturers are going to be looking at that to see, okay, what type of area can you put the equipment in? The minimum ignition source. It's like a spark plug. You push the button on your propane grill and you get a little spark. Well, that spark is 20 to 30 millijoules. Notice the ignition limit of propane is 0.25 millijoules. And understand, a millijoule is a measurement that I don't want to try to even explain. It's just a number. But when you see the propane will go to a 0.25, that's a much lower level than a spark plug. The spark plug is going to ignite it. 2L refrigerants have a very high ignition energy requirement. So general household items are not going to ignite the 2Ls. They also have lower flammability limits. So it's not one of those problems you're going to see. The heat of combustion, though, is, how hot does it get? How fast does it burn is the flammability. So when you look at the burning velocity, if you see in the 3 pictures, an A2L known as 1, 2, 3, 4 only burns a little bit. And what's going to happen is the flame in front of it is not going to keep burning. If you look at the R32, it burns a little faster. You look at the A3, it'll continue to burn all by itself. It'll keep moving out there. If you've all worked on a system that had refrigerant in it, you know that all refrigerants will burn. If you hold a torch to them, they will burn. Unfortunately, I have had my body lifted out of a deli case when we were still using 12, and I had a torch in the case and we hadn't bled the refrigerant lines out enough. And I got a real good whiff of phosgene gas with my torch and the refrigerant, and I was out cold in the case. Thank God there was somebody right behind me to lift me out. These are the classifications that ASHRAE Standard 4 lists. There's no real debate on these. They've tested all of this. You know what low toxicity is? Most of the stuff we thankfully work for and work with is an A refrigerant. It has low toxicity. B is a higher toxicity, which is like ammonia. Flammability, though, it's a special classification now with the A2L, because they had to come up with something that would burn a little bit slower, and naturally synthesizing these in a factory makes life a lot easier. The chemists know how to put documents and things like that together to make sure things burn at different levels to satisfy the underwriter laboratories and the other fire protection associations and things like that. So when you start to look at safety classifications and such, the high flammability, right now we don't have a refrigerant that's highly toxic and highly flammable. We are using 290 and 600A. There's a couple of refrigerants that are used, 152A and 611 and 40 that are a little toxic. But if you'll notice, the lower flammability level area is where most of the equipment that's being talked about for the heating and the air, well, the air conditioning industry and some of the light commercial stuff is the R32 and the 1234YF. 717, you already know is in use. Ammonia's out there, but ammonia does burn. 22, 410A, you know, they've been out there for forever. But when it says no flame propagation, what you have to realize is you have to, for propagation, you have to be able to light it and it stays lit. With an A1, you can put a torch to it, it'll burn, but it's not going to stay lit. And I know you've all experienced that. This is what you have to look at in the way of a number of different flammability classifications. Do you see my pointer moving around?
Yeah.
Okay, well, here's the lower flammability limit of 32. Now, when you start to work your way across, where did it go? Okay, it jumped around. You get over here to propane, 2.1% as opposed to 14.4%. That's why this is classified as an A2L. It doesn't, you know, it doesn't light real easily. As you can tell, it has a much higher ignition point, as you can see in comparison to propane. It's going to just require a lot more energy to ignite it. But you'll notice, you know, 1234YF requires even more millijoules to light. It's just a massive amount of energy, whereas propane, it's a much lower level, right? Its burning velocity, it doesn't burn real fast, as opposed to propane. Propane just burns very fast, and propane's hot. If you've ever worked with natural gas, cooked with natural gas in your home, as opposed to cooking with propane in your home, propane just seems to cook faster, even though we have different size orifices and everything that goes along with that. We used to work with propane and cook with propane. My wife always complained about the fact that this stuff cooks faster than I'm used to with regular natural gas. So these are just all the various issues of how you're going to handle the the safety of these. Now, the safety, it's not much different than the safety you've already been going through. You worry about any ignition when the equipment's in operation, when you're servicing the equipment, release during a structural fire. As my father's shop burnt down years ago, there was plenty of refrigerant that the relief valves let go on the tanks, and it added to burning the shop down. It added some lovely colors to the flame, but the stuff burns. So those are the three things that, you know, the NFPA would be looking at when they evaluate refrigerants, and knowing that you're going to have refrigerants that are flammable in a building, the fire departments are going to want to know about that. The toxicity levels, if this stuff is released inside your vehicle or a leak in a confined space, the burning of that refrigerant while servicing it, that's a toxicity issue. But one of the things that you really want to remember is before you work on a system, purge it with nitrogen before you do any service work. Always take and bleed it through to get all the flammable refrigerant out of the system. Because if that flammable refrigerant isn't out of there and you light that torch up, you'll add a little extra flame to it. As I did see when one gentleman that I was working with on an A3 piece of equipment said, yeah, it's all gone, but there was some trapped in the oil in the compressor. And he was brazing and he hit the compressor with his arm and it shook it just enough so that the refrigerant was released from the oil, and it caused a little extra flame. Let's just put it that way. So follow those extra precautions. You're all working safely with the equipment now. You know, when I would be in a classroom, I would actually ask people to hold up all your hands and look for anybody who had lost a finger or had really burnt hands due to working in a way that's not safe. You know, you have to have your personal protection equipment, but also remember that these refrigerants have been in use for a long time, and you know, you're going to work safely with this stuff. It's just no question about it. Does anybody have any questions so far?
What would the process be, Pat, to ensure that you don't have any more refrigerant in the oil? Running the crankcase heater, obviously, if there is one, or maybe a heating blanket?
You probably add a heating blanket. You know, it's going to be your crankcase heater. If the system has one, you're going to have to hope that you can recover the refrigerants. A3s do not need to be recovered. A2Ls do need to be recovered. All right, and I mean, that is a very important aspect that you have to remember. I will tell you, A3 refrigerants, when they first came out, there was no information on how to recover them. And enterprising people came up with different ways to do it. A couple of people came up with a container that you would put as a water filter on your home, one of the big charcoal filters. They would evacuate it. They would attach it to a propane system, suck all the refrigerant out. It would turn it into an inert gas, and they throw the cylinder away. When I was doing a training at Cornell University, they said all the refrigerants must be recovered. I explained that recovery system for the A3s, and then they were satisfied and they would accept a piece on their campus. But before that, they wouldn't. There are locations where you're just not going to be able to install A2Ls and A3s. Certain hospitals that I know of will not accept them because of the other dangerous pieces of equipment that they have that could cause an issue. So the application. Go ahead.
What is the recovery process for the A2L?
We'll get to the recovery process. It's, you know,
Okay.
It's really no different except for making sure the equipment will handle it, and depending upon the charge and such, that you follow the amount that you're supposed to take and recover down to whatever that level is. That's information that's, you know, coming from the manufacturers, depending upon the size of the equipment. And that's one of the issues that you have to look at, which is it's only allowed for new systems, and the systems for A2Ls have to be designed to mitigate. And if you don't follow the manufacturer's installation instructions, it's a real problem. But A2L refrigerants have been in use in refrigeration systems in Europe, Australia, Japan, and all over the place for an extended period of time. The A3s have also been in use. Manufacturers have been sending A3 beverage coolers, let's say, to Europe since before 2010. So there's a real good history on these pieces of equipment. An example of a propane system is just go to a checkout counter and look at the impulse buy soda cases. A lot of them now are propane. But there is labeling requirements. When you get to A2s and A3, to A2Ls and A3s, there's a lot of labeling that has to go on these things. This particular label over here will be more prevalent for the A2Ls as opposed to the A3s, but they may add this to the A3s at some time in the future. You will also see these different requirements in the way of showing flammability. Here it is, the flammable gas. These are all labels that are required to be on things. Warning labels that you have to have. If they come off, replace them, get new ones, call the manufacturers for them. They all have to be there, especially considering that the next person along may not know it's a flammable refrigerant. And you know, you're working as a company and as a team, and you don't want the next guy to wind up burning off, you know, his eyelashes and his eyebrows and the front part of his hair because somebody didn't give him the information. These are just you know, some of the different labels that you're going to see on the equipment. You can see the flammability there, flammability here, flammability here, and understand that if it's a split system, these labels have to be on both pieces of equipment. So you're going to be getting these pieces of equipment probably, hopefully, from the same manufacturer, and they will know that they have to put the labels on these pieces of equipment, and the labels will be there to make life much easier. These are actual pictures of propane units that are in the field. Now, these sleeves right here are just simple plastic sleeves. They'll be marked in what's known as the Pantone Matching System number 185 red. It's a red sleeve. Will it change color over the years? Probably. You know, it'll get dirt, dust, heat, this, that, and the other thing. It'll fade, but those have to be there. Now, it's always been my suggestion that if you take one of these off while you're working on the equipment, you put it back on after you're done. But the other thing is, if you damage it or you break it, or it gets swept up while you're working on the equipment, but you have a really great apprentice working with you, and he grabs it and cleans up after you as you're going along, do something like paint the label, paint it red, wrap red electric tape around it, maybe label the back of the unit, just so whoever follows you knows that he's going to be facing R290. It's like putting a control in something and not going back to replace it. If you put and change any controls on these pieces of equipment, you have to make sure they're rated for the A2L or the A3 refrigerant. And if you replace it with anything else and it causes a fire, that's an issue. You always replace it with something that is rated for the refrigerant that's there. So just make sure that you continue to do and mark the things the way they've been marked. You have the standard job safety. it isn't changed any. If you have to, and shut the system down, lock it out, make sure your area is well ventilated. If you have to set up a work area around you. Now, you don't want, if you're working with the A2Ls, you don't want somebody leaning over top of you who doesn't know what they're doing and causes you a distraction. So put some cones out, keep the people away from you. It's just a matter of safety, which I believe, since you're in a training room like you have, you're all following the safety standards. Wear your safety glasses. If you have to on the job sites, get butyl gloves and make sure you use the butyl gloves to make sure you don't freeze your fingers. I've seen one absolutely incredible picture where someone had a leaking refrigerant tank and tried to stop and put his hand in the refrigerant, and his hand was black. So just be prepared. It's a safety factor. You are never going to swap out existing equipment. All right, you always have to use new equipment for the A2Ls. It cannot be, well, I'll have a coil inside and an A2L unit outside. They have to be matching because it's just part of the requirement. They have to be sized to fit the existing space. The A2L systems are going to have manufacturer literature that is going to help you to size the equipment for the amount of refrigerant that you have to put in the system, because when you're dealing with it, there will be maximum charge sizes, and the maximum charge sizes don't have to do with just how long does the refrigerant run in the suction line and the liquid line. It also has to do with how big is the space that the system is going to be installed in. The manufacturer's literature will have information on that. It will help you to understand, you want to make sure that you don't put too big a piece of equipment in for the area, and then if the refrigerant leaks out into that area, you reach the lower flammable limit. Because if there's any ignition source in there, like a fan blade scraping, that could cause an ignition source. So you're going to have certain mitigation requirements. Some of the A3 units that were being shipped into the United States didn't meet the DOE standard because they used a mitigation methodology where they took for a self-contained unit and they ran the condenser fan all the time. It constantly blew away any issues with the refrigerant getting to lower flammability limit. But when you start to deal with the split system and your condenser is outside and your air handler is up in an attic, if the leak is, let's say, in the attic, you have to make sure that you do have the mitigation methods. Some of those mitigation methods will be literally where your system will automatically shut down because it regulates and knows that I've got a refrigerant leak and short of gas. Others will be sensors that are put in there, all right? Active refrigerant alarms, permanent space ventilation, running the blower whenever there's a refrigerant leak, pump down systems. They're all ways to keep the refrigerant at less than the lower flammable limit. So as you go through these things, just be aware that some of our methods that have been used in the past are still going to be used today. The room sensors. If you had a big enough piece of equipment in a small machine room, you could have a leak, which I have seen, 150-ton heat pump in a mechanical room that did not have the proper ventilation, and it sprung a leak. 2,000 pounds of R22 leaked into the room. We carried a couple of people out of that room. Thank God they were all right, but we carried them out. So, having alarms in these rooms, having the space ventilated, constant airflow. Now let's understand also, if you have a leak of some nature, this is the kind of alarm you may have. It may shut the system down. may shut it down, it may pump it down, it may turn on the blower fan and just circulate it constantly to prevent it from reaching the low flammable limit. But these pieces of equipment need to be tested and serviced, and the sensors are just something that may have to be replaced every once in a while. So the manufacturers will be putting these in the equipment, and it will be the manufacturer's manual that you're going to have to follow. The next one is where you get to some real fun and games. Because it's a flammable refrigerant, just like you do with running Romex through studs, you have to protect it at times. So as you can see, we have protective shields that are going to have to be installed. It's just, making sure that you do these things. So sometimes when you're replacing a system, the inside and the outside, you may run into a circumstance where you can't use the existing tubing, but you're going to have to make that decision because every job's a little bit different. When you're working on any of these systems, purge the system, make sure all the refrigerant's gone, especially that, the stuff that's in the oil, even if you have to heat that a little bit with a blanket, beat it with a hammer a few times, a rubber hammer, please, so you don't ruin the compressor and your hammer. But the tubing has to be pressure tested, all right? And that's all normal. We all pressure test our systems. Now here's the fun and games. What do you pressure test to? Which pressure would you choose, 150 or 400?
150.
150, everybody agrees on 150? Okay, guy in California has an evaporator, starts to leak. He gets a new evaporator, replaces the evaporator, doesn't look at the design pressures, the low side pressure, because the evaporator's on the low side, and he repressure tests the thing to 400 PSI. Blows another return band. On the fourth evaporator that he got, they sent it with the field service tech, like I would have had to go if it was on the East Coast. And as soon as the guy got to 150, the service tech said, he said, what are you doing? He said, well, I'm pressure testing it to 400 PSI. Stop. And he said, that's why you've gone through 4 evaporators. So just, have your technicians follow that information. Make sure they protect the tubing, because if it's A2L and somebody drives a nail through it, it's going to be a problem. Once you pressure test the system, because of the A2Ls that we're going to be working with, you cannot add any more dry nitrogen to it. You got to let it sit. You have to, not have a pressure drop for the system to pass the test. You all know, and you all probably have electronic micron gauges, because after you've pressure tested it, you're going to evacuate it to 500 microns, just like normal. But you're also going to do a micron evacuation test, shut it off, disconnect it, isolate the vacuum pump, and see if the evacuation rises. If it gets to 1500 in 10 minutes, you probably are going to have a leak. If it's a brand new system, that shouldn't happen. If it's an old system, you may be just getting some of the residual refrigerant out of the oil that's in the compressor. You're going to have to evacuate it again. There's not too many different things that we're really covering here, except for the fact that you're going to have to do these things a little bit. You can see the gauges. I don't know anyone that could have ever determined the difference between these two in the way of microns, although we all did it years ago. We just let it run for a certain amount of time, and that was a good evacuation. You can't do that with the A2Ls and the A3s. You just have to get them really evacuated. Now, when you're doing the evacuation or the recovery, you have to use a piece of equipment that's designed for A2Ls A3s, because if you don't, and something happens and there's anything trapped in the system, that vacuum pump may cause an issue for you. The recovery system may cause an issue for you. So make sure that you use the proper unit. If you don't, there could be a flame, and your vacuum pump and your recovery system could wind up on fire. It's no other way to say it. Make sure that the system's down to zero pressure. You haven't left a little bit of nitrogen in the system. Thank goodness today we have some of our equipment that is oilless. But if you've ever worked on a system where somebody forgot to take all the pressure out, you test your vacuum pump, and the next thing you know, it's the refrigerant is blowing the oil out of your vacuum pump, and you're cleaning up and then have to replace all the oil. You know what the issue really is. Just make sure you've done the recovery. When you're going to evacuate it, some manufacturers require multiple evacuations, triple evacuation. You've got to get it to the industry standard of 500 microns, and it's got to stay there. If it starts to rise, it's either coming out of the oil, you re-evacuate it, do it maybe a couple of times, but if it continues to rise, you probably have a leak, which means that your pressure test, when you pressure tested it, didn't last long enough. All right. When you're working on a system, and this is going to happen because, after a while, there's going to be A2L systems that are out there, and it's sprung a leak, and you have to do something to it, or a compressor burnout, or whatever. You may have to flush the system out. All right. You may have to do the triple evacuation. You may also have to exhaust to outdoors. If you're working on a piece of equipment, let's say, and it's in a commercial kitchen, and you're next to the fryer, you sure as heck don't want to be exhausting A3 refrigerant into that room. You want to put it either through a long hose to outside or up into the exhaust hood, whichever way you can get rid of the refrigerant. All right. Flush that oil out of the lines if you have to, because the oil in the lines is going to cause just as much of a problem as not getting it into a deep evacuation. If you have a burnout, make sure you do a cleanup and flush the system properly to take all the contaminants out of the system. I imagine you all know that the refrigerant cylinders are changing. We are no longer going to have colored refrigerant tanks. They're all going to be gray. But the nice part about the flammable refrigerants is there will be a red stripe on the tank. And you want to always remember to read the labels. The ruptured discs that you see here, because we are going from disposable tanks to reusable tanks, these ruptured discs are going away. There will be, and I think the relief valve is right about here, but you want to make sure if you get a real hot day and that relief goes inside your vehicle, open the truck and let it ventilate. If you have these tanks laying down, you can have a major issue with the leak through the relief valve. And I have seen this when you walk up to your truck and you have liquid refrigerant pouring out of the side of your truck because the 125-pound bottle of 22 let the relief valve go because it was laying on its side for just transport to another spot. And it was kind of funny looking at the police officers and all the people around the vehicle. Thank God it was before the EPA decided that we had to have the licensing to handle refrigerants, because it was about mid-80s when it happened. So keep the tanks standing up vertically. You're also going to have different storage areas in your shops and things like that. but that goes back to the authority having jurisdiction in your area. You know, what does the local fire marshal say if you're storing, you know, refrigerants? The distributors will have more of a handle on that, how much you can keep in place. But you know, you may want to just check with the authority having jurisdiction or the local fire department. Say, look, you know, the new refrigerants are flammable. They'll want to know about it, especially if they have to come to your location for anything. There are code limits and on the system design and the capacity of the systems. The processing of this overall is just, it's very interesting, because what happens is you have to look at, okay, I've got to keep the indoor volume to such a point where I won't reach the lower flammable limit. The maximum charge is not going to be universal, and it's going to be different for every system, just like it is now. But the allowable charges for A2L has to do with ventilation and without ventilation. So some systems be charged when it has ventilation, meaning you could have a mitigation circumstance where the fan runs all the time. But just remember, you know, the manufacturer's literature needs to be adhered to. It needs to be followed, and you need to read through it. The system is being installed in a certain occupancy classification. You know, an assembly building is going to have a different requirement than a residence. And I think I saw something today that IATMO on their mechanical code did not accept some of the changes to the code that were approved by the overall general body. So that's one of the things, depending upon the code you're working on, will you be able to even use the A2L? Your local distributors will know that. But there are a number of states where they're still working off of codes from 2000 and I think I saw one of 2007, and here we are in 2022, and they haven't updated their codes. Although the standards that the codes are built from have been updated, it just takes time to go through this whole process. Locking rings. You want to prevent unauthorized access to these systems if you can. The new tanks, as you can see, are going to be gray and red if they're flammable. The other tanks are all going to be gray. And slowly but surely, all those tanks are going to disappear that are out there that are color coded now. That law went into effect, I believe, in 2000 is when the changed colors of tanks went into effect. Your gauges, your manifolds, your hoses, everything has to be rated for A2L refrigerants. This is the fun one. Generally, you have to fill this out. You have to put the company name, the evacuation level, and a test date, the leak test, the date, the type of refrigerant, the total charge in the system. And in some instances, manufacturers are requiring you to take a picture of this and send it in to them to make the warranty be effective. If they don't have this, there's no warranty on the piece of equipment. And if there's topping off, as you can see, you have a number of service record locations. If you're topping this off once every 3 years or something like that, there's probably a leak in it. Unless somebody's not being careful putting a locking cover back on or a Schrader back on, you should re-leak test the entire system to make sure that you don't have a leak. When you're disposing the cylinders, don't go drilling them. Take a punch. As you can see, this particular punch is pretty much a brass punch, which is not going to create a spark. But you know, you've got to puncture these things so they're no longer usable, so you can dispose of them. All these tanks will eventually go away because everything's going to reusable tanks. If you've recovered the refrigerant and you're going to be working with a torch or anything like that, take the tank that you recovered the refrigerant into and move it away from the work area. Also with the ruptured disc, if the ruptured disc goes, you're going to lose all the refrigerant. But with the relief valve, it's going to reseat. And if the relief valve is lifted, you probably want to check the tank. You want to check the relief valve. You want to make sure it's reseated. And if it does it more often, I would take the tank back personally, because I don't know if it's going to reseal properly. But that's pretty much it. Now, how deep an evacuation, you know what that number is. For the recovery, the manufacturers are going to be supplying that information, but again, it's going to depend upon the size of the area you're installing it in, how much refrigerant's in it. So it's, it's go back to the EPA standard, look at what it should be for a certain piece of equipment, and take it down to that evacuation level, let it sit for a while, and then re-evacuate it and recover it again, because you're basically, once you're sucking it down into a 10-inch vacuum, it's being evacuated. Make sure you do this. It's basically the same way you've been working for the last who knows how many years, except now you have a refrigerant that you're going to be very careful with, and that you want to follow the manufacturer's instructions more carefully. If you don't, you could have a flammable ignition system, and you just don't want to have that. So, does anybody have any questions?
This is really going to change the aspect of changing equipment, new installs, retrofits,
The whole learning curve.
the safety aspect is going to be,
Well, just those, rebuilding cylinders is gonna cause an issue.
oh, yeah.
I mean, holy crap.
Hell no, don't put them on their side, yet every van's got a rack where they all go on their
Yeah, you
side.
got 25 of them who gotta fit in your truck, because they're all different, they have all, right? The recovery ones and also the.
You need a travel trailer just to carry on.
Yeah, no, sad.
Would it be nice to have a separate travel trailer so that you didn't have to worry about the refrigerant leaking in your truck?
Oh, that too. Each check will be assigned a refrigerant. Oh, you need the 1, 2, 3, 4 Y guy. Yeah, PR32 guy. We'll see if we can pencil you in at 6 months.
Think of it this way, in a couple of weeks, I have to go into New York City and do a presentation for contractors in New York City on the same stuff. And the first question I know I'm going to get is, well, can I take this through the Queens Midtown Tunnel?
Right.
I know for a fact that the contractors were taking the small bottles of 290 through the tunnels
Yes.
because I rode with them. But when you start having 30-pound bottles, it's just like having a propane tank. You got to take the bridges.
Huh.
Oh.
We don't have tunnels that we go into.
You're lucky probably in your area you don't have those particular issues. But if you go out to Pennsylvania Turnpike, there are four tunnels, if I remember correctly, going from the East Coast out to Pittsburgh that you're really not supposed to be going through with propane tanks. And it doesn't matter the size. A2L will probably fit in the same category. The Department of Transportation will set those standards, and that'll be on the tank and the information. So a lot of this boils down to following the manufacturer's installation instructions. You're just not going to do a swap out where you just change out the condensing unit and put a 2L system in, because it wouldn't match the existing piece of equipment. You will have to change the coils. If you're thinking, oh, the tubing is going to be going through the studs and you're putting a 2L in, you may not be able to use the old tubing. You may have to run new tubing. And like, with most of the Mitsubishi, Daikin, Sanyo type systems, they run the tubing on the outside of the building in a similar to a gutter guard, which makes it look nice. So you may be running refrigerant tubing more outside.
Pat, walk us through charging a unit.
Say that
And then-
again.
Walk us through charging a piece of equipment from new, and then how do you, if you're gonna charge by weight, say you have 3 pounds of 290 that you put in the system. And the tag,
First off, you're never going to get the 3 pounds in the 290 system.
I understand.
Yeah.
What I'm getting at is you had the tag there with, let's top it off. How do you know? If you're weighing it in, you have to suck it back out to know how much you've lost, right?
Yes, you would have to take and remove all the refrigerant. All right, put it through an evacuation, do on a 2L, you're going to recover the refrigerant. All right, then you're going to take it down to the EPA required, let's say 10 inches, depending upon the size of the piece of equipment. Then you're going to repressure test it to find the leak. After you find the leak, you're going to repair the leak. Then you're going to repressure test it. Then you're going to evacuate the system. And in most instances, what you can do, depending upon what the charge is, you know, if somebody's put it in properly in the first place, the label will be there. But they're also supposed to leave the manufacturer's installation instructions behind so that you can read it to find out, okay, this is how this system is charged, because each system will be charged a different way, depending upon, you know, the length of the lines. But, you know, you only have so many square feet and cubic feet in an attic, and you've got a air handler up there that has a 2L coil. That particular coil, if it springs a leak and dumps all the refrigerant into that attic has to be big enough to have handled all the refrigerant and not reached the 2L level. So in some instances, the piece of equipment you select may not work, which is going to be another challenge for you in the field. But how do you charge it? For weighing it, the way we used to charge the A3 systems, you would literally have it evacuated, and then you would take a refrigerant tank, you would connect it to your gauges using short hoses, because you were going to be weighing it in. And the shortest possible hoses, actually, some hoses came out of, they came out from somewhere that were millimeter size, and they held such a little amount of refrigerant, it wasn't even funny. I think it was like 0.2 ounces or something like that. But when you were charging a system that needed 2.4 ounces, you know, you had to be critically charging a piece of equipment, and you would take a tank, you would fill the lines, bleed the lines, and after you bled the lines, you would put the tank on a scale. Some people put it back in the box and then zeroed it. Newer tanks now are naturally going to be able to be stood on the scale or turned upside down, generally depending upon the refrigerant, and it will depend upon the other refrigerants that they develop, whether or not we wind up with much glide or anything like that. You're going to just weigh it in, and you're going to have to put it on the label. Now, it's going to have the manufacturer's information on, all right, am I going to be using superheat? Am I going to be using subcooling? It's all going to be a manufacturer specific. Each manufacturer has different IDs on that. I mean, I can tell you, if I look at a label on a, let's say, a reach-in thing, and it says 2.4 ounces, I'm putting 2.4 ounces in there as close as possible, because once the line's been bled, once I open the valve on my gauges, I'm going to bleed that right in. I'm just going to watch the scale and then shut my gauges off.
So the tag that you were looking at with the top off dates and signatures on it was basically, that's what confused me, is that there really is no way to top it off when you don't know what the charge is in the first place.
If somebody hasn't filled this in properly, first off, you don't know what the total charge was. So you're going to be starting from scratch because you need to take the charge back out. Should you be topping it off? I don't believe so. I know we have all done it. We have all done the topping off. There's no question about it. You've got a slightly leaking Schrader fitting that somebody didn't tighten the cap on properly, or the gasket inside the plastic cap was missing and it was leaking. This is the challenge that we're all going to be facing out there in the field.
So in reality, you're not topping it off. You're pulling a charge out to see what you got,
Right.
like we said a few minutes ago. Okay.
You're not gonna pull it away, get rid of it.
You're gonna pull the charge out and weigh it as you're doing it. If it's clean refrigerant still, you can probably put it back in, but if the person who did the original installation did not put the information down on the total refrigerant charge, you don't know if it needs to be topped off.
Or that it's accurate in the first place.
Okay,
Exactly.
when it's running and you've got gauges on it, you can look at the pressure and temperature. You kind of know where you're supposed to be, sort of. And you know it's good. But you can get, should be able to get close, right?
Should you be able to be close?
No?
Depending upon the system, you might be right on the money. You might be a little high. You might be a little low. You can't just look at a set of gauges and determine if the charge is proper. Because, the very first thing you have to do is you have to look at the airflow. Do I have the right amount of airflow on my system? If I don't have the right amount of airflow on a split system, I don't know if I'm going to boil off all the refrigerant in that coil and make sure that all the refrigerant coming back to the compressor is vapor. So, you have to go by what the manufacturer is saying in regard to superheat, subcooling. You have to hope that the original installing technician and company did what they were supposed to do in the first place. These are the challenges we're facing with the A2L systems. So topping off is going to be just one of those things, Is it going to happen out there in the field? You all know, and I know, people are going to be topping them off. They're going to look at it and say, my pressure doesn't look right. Now, if it's a packaged unit, you can take the refrigerant out and recharge it by the weight. But if it's a split system, you have to take all those other things into consideration, like the cubic footage of the area where the air handler is that has a coil in it that could leak into the room. That air handler, it may literally have a mitigation method where it senses a leak and it turns the air handler on and just runs the air handler constantly. It doesn't shut it off because there's a leak, and that way you don't reach the lower flammable limit.
Well, are the manufacturers set on all this stuff now? They know what they're building, and there's not going to be too much of a change.
Well, the manufacturers know what they're building, and they've had to have their equipment tested. It's very critical to make sure you have your equipment tested by UL, AHRI, ASHRAE, NFPA. Everybody joins in to check these things and check to make sure that they meet a good standard. And on top of that, they have to meet the DOE standards. So, by the time they're done going through all the different organizations that they have to have checked off on the equipment, they have got this stuff down pretty well. They have to have it in their installation instructions. I can't say strongly enough that you have to read those installation instructions down. The classic I use is the installation instructions that are bad for for the Instapot that I have. My wife and I use it, and in nowhere does it tell you after you pressure test, pressurize something, you know, you use it as a pressure cooker, you have to take the pressure off. You can't just put it on warm. You have to take the pressure off and restart the process. Nowhere in the instructions does it tell you that. So the manufacturers have spent a lot of time learning and understanding and writing the instructions to go along with installing this equipment. But again, it's a certain amount of it's engineering, and the engineers have to go through the information and make sure the information is correct. Topping it off, you know, if you've got one system that's got 10 foot of refrigerant lines and another system that is 20, you're going to have different charge. Will you be able to tell it by just looking at your gauges? Not without looking at the manufacturer's installation information to see exactly what the superheat, subcooling, or whatever methodology they want you to charge by.
Understood. So as a contractor in the early 90s, everybody jumped out and bought a bunch of different kind of recovery machines.
Right.
And then things changed drastically over the years, obviously. The recovery machines and hoses that are available right now today, are they going to be something that we can use for the next 10 years, or are we going to be looking at new generations of that?
You know, right now, the new systems, the new recovery systems, and the new evacuator and the suction, vacuum pumps are rated for A2Ls and A3s. And if they're rated for that, you're covered. The hoses, as far as I know, from the distributors I've talked to, they're all rated for the A2Ls and the A3s. Now, I've seen some contractors who have separate sets of gauges for each different refrigerant they work with. I've also seen contractors who have one set of gauges and they just use that one set of gauges. As you could see from earlier, this is a set of gauges that handle 600, A32, and 290. So the equipment is out there. Will it last 10 years, or will there be a new refrigerant that comes down the road? I can't tell you that. You know, could there be another SNAP approval for something else?
Okay.
Quite possibly. I mean, could somebody figure out a way to make CO2 work on a real small system basis? Anything's possible.
So basically, we wouldn't throw money away by tooling up a truck or two right now.
No, I don't
That's-
think you would.
Okay.
I don't think you would, because this equipment is already in the field and being sold in certain instances. You naturally have to check with your local distributor and see if they're handling it. But in certain parts of the country, certain parts of the certain energy efficiency pieces of equipment are no longer being allowed to be sold.
What are the largest pieces of equipment with these A2Ls in them being sold right now?
Currently, off the top of my head, I do not know.
I thought there was a limit on how much of this flammable refrigerant could be in the system.
Well,
Your small reach-ins.
the small reach-ins and such, you know, they're very,
Keep trying
very
to lose
small charges of A3s.
5 tons pack doing this shit.
It's been around for years, yeah.
You know, when you get into split systems,
Like-
it's
Too-
being
That's-
able to quantify it, that it can fit in the space that you're going to install it, and not have that unit cause a problem of going and leaking totally into that area and being at the lower flammable limit.
You said something earlier about the evaporator size and the room that it's in. But if you get a leak in your evaporator, you can bring condensers in there too. It's the whole system gonna leak in there.
That's correct.
Yeah, not just the evaporator.
Right, so it's.
That's
Any
why,
space that the system fits. Even the code people get crazy if it goes through a closet, that closet will be ventilation.
Oh,
In case you get a leak in that line sit there. Give this.
Oh, boy.
They look as though they got fans, but when you do your reclaiming, you have to set a fan up, even.
We don't do reclaiming.
Questions already come up. I read an article about the multi-head ductless splits, you know? You've got two of these systems in, and each one's got 4 heads. You got this refrigerant piping running everywhere inside of this building. Are you gonna need toxic refrigerant detectors in this office space?
You may need a sensor.
Depends on what municipality you're working.
Yeah.
Depends on the classification. Is it an is it an assembly building? Is it a residence? Is it an industrial building? They'll all have different classifications.
Too hard, I don't wanna do it no more.
You know, you were talking about the pressure testing a bit ago. I was kind of laughing about 25 or 30 years ago. I did a piping on a Liebert job. The guy insisted that I put it 500 pounds, the inspector. And I showed him on the tags, it says, don't exceed these pressures. And we chased a leak for a couple of years on that. And it ended up being a fusible that when I got hot, the fusible would weep.
I believe we've all seen the super small pinhole leaks that they only really leak when
You're not there.
when you're not, definitely when you're never there, but they only leak when you get high head pressure.
Yep.
It expands it just enough so then it starts to leak, and it happens.
Anyone else have anything else? Guys set?
Everybody good?
Patrick,
Hey, listen, I want to really thank everybody and understand that if you need training materials for your training room or something like that, just go to the ESCO group. We have a training manual for the A2Ls. It's pretty comprehensive. It covers the information. This PowerPoint has been developed from a lot of that information. So it's just a matter of, if you need the extra training material, you can get that from the ESCO group.
already working on it, Patrick. Appreciate it.
Hey, no problem, man. Everybody have a great evening. Be careful driving home. I hope you don't get too much snow. If you're supposed to get snow, but supposedly, the warm.
It's all rain mixture.
More again.
Don't forget to send me your snail mail, Pat.
Yep, I will. Okay.
All right.
Thank you all. Have a great evening.
Appreciate it. Thanks so much.
He's ready.